Welcome to MRL. In this learning session, let us learn the solutions of the examples of exercise number 2.2 of the Polynomials chapter of 10 CBSE textbook. Now, in the first example, we are to find out the zeros and verify the relationship between zeros and the coefficients. We are given a quadratic polynomial x square minus 2x minus 8. We have to find the zeros of x square minus 2x minus 8, and that we can do by the middle term splitting method. Now, by going by middle term splitting method, we know that, and please remember, learn how to do the middle term splitting method. If you are not sure of the middle term splitting method, please go through the factorization methods which we have already discussed in one of the videos which is uploaded, to learn how to carry out the factorization of given polynomials. Now, this is done by middle term splitting method here. So the factors are x minus 4 and x plus 2. If x minus 4 and x plus 2 are the factors, that means to find out the zeros, we have to equate x minus 4 equal to 0 or x plus 2 equal to 0, because you know that the value of the variable if it satisfies the polynomial, then the value of the polynomial becomes 0. So the factors are also equal to 0. So x minus 4 equal to 0, x plus 2 equal to 0, x is equal to 4 and x is equal to minus 2. So the zeros are x is equal to 4 and x is equal to minus 2, or alpha is equal to 4 and beta is equal to minus 2, because you know that the quadratic polynomial has a maximum of 2 zeros, and if the zeros are alpha and beta, here we have alpha is equal to 4 and beta is equal to minus 2. Now we have to verify this relationship with the ratios of the coefficients, with the coefficients given. Now let us understand here, to verify the relationship, we know that alpha plus beta is equal to 4 minus 2, and that is 2, and alpha into beta is equal to 4 into minus 2, that is minus 8. Now let us find out the relation between the coefficients and the zeros of a quadratic polynomial. We know that the sum of the zeros is equal to the coefficient of the negative times the coefficient of x and the coefficient of x square. That means it is minus b by a. So alpha plus beta is equal to minus of minus 2 divided by 1, and that is equal to 2. Alpha plus beta is equal to 2. Now to find alpha beta is equal to c by a, that is the constant divided by the coefficient of x square, and that is minus 8 by 1, and alpha beta is equal to minus 8. So we have here alpha plus beta is equal to 2, which is equal to minus b by a, and alpha beta is equal to minus 8, which is equal to c by a, and that is how we verify. That is verification of the relationship between the zeros and the coefficients. Remember that. Now coming to the next example, again the second example is the same again. We are given a quadratic polynomial. We have to find the zeros first. So let us go for middle term splitting method again, but here we find this is a square term. This is a polynomial wherein we can apply the what you call identity. Now 4s square minus 4s plus 1 is definitely 2s minus 1 whole to square, that is a minus b whole to square. A minus b whole to square is a square minus 2ab plus b square. If we apply that, we get 4s square minus 4s plus 1. Therefore I have used the identity a minus b whole to square here. So now to find the zeros, I have to equate the polynomial to 0. That means I have to equate 2s minus 1 equal to 0 and 2s minus 1 equal to 0. Simplifying, we get x is equal to half and s is equal to half. So the alpha, that is 1 0, alpha is equal to 1 by 2, and the other 0 beta is also equal to 1 by 2. Rather, both the zeros are equal to 1 by 2. Now to find alpha plus beta, let us find the sum of the two zeros, that is half plus half is 1, and the product of zeros is half into half, that is 1 by 4. Now let us take the ratios of the coefficients and the constant here, that is alpha plus beta is equal to minus b by a. Minus is minus 4 here, so it is minus into minus 4, and a is 4, so it will be 4 by 4, and that is 1. Alpha beta is equal to c by a, c is 1 and a is 4, so therefore it is 1 by 4. That means alpha plus beta is equal to 1, and that is correct, 1, and alpha beta is equal to 1 by 4, and that is 1 by 4. Therefore alpha plus beta is equal to 1, which is equal to minus b by a. Alpha beta is equal to 1 by 4, and that is equal to c by a, and that is how we verify the relationship between the zeros and the coefficients of a quadratic polynomial. Now the third example, again it is a quadratic polynomial given, that is 6x square minus 3 minus x by middle term splitting method. We have to find out the factors first. The factors are 2x minus 3 and 3x plus 1. If I have to equate the polynomial to 0 to find the zeros, I can equate the factors also to 0. Therefore 2x minus 3 equal to 0, 3x plus 1 equal to 0, or x is equal to 3 by 2, or x is equal to minus 1 by 3. So please learn the middle term splitting method to prove this, that relationship between the zeros and the coefficients of a quadratic polynomial. So we have got the one polynomial alpha as 3 by 2, the another one 0 as 3 by 2, and another 0 as minus 1 by 3. So therefore the sum of the 0, that is alpha plus beta, is equal to 3 by 2 minus 1 by 3. Taking the LCM, we get minus 9 minus 2 by 6, that is 7 by 6, and alpha beta is the product, that is 3 by 2 into minus 1 by 3, 3 cancels, we get minus half. Now let us take the relationship, that is alpha plus beta is equal to minus b by a, and as you know, minus b is minus 3 here, so minus b is minus 7 here, sorry, minus 7 here, so it is minus of minus 7, and a is 6, so it will be 7 by 6. Now alpha beta is equal to c by a, and c is, as you know, it is that is minus 3, so take minus 3 divided by 6, and that is minus half, and therefore we find alpha plus beta is equal to 7 by 6, which is equal to minus b by a, and alpha beta is equal to minus half, which is equal to c by a, and that is what is the verification of the relationship between the zeros and the coefficients of a quadratic polynomial. Now the next example is 4u square plus 8u. Now 4u square plus 8u has to be equated to 0, and to find out the zeros of this given polynomial. Now 4u square plus 8u is equal to 0. Taking u common, that is 4u common rather, 4u in the bracket u plus 2 is equal to 0. So 4u can be 0, or u plus 2 is equal to 0, u is equal to 0, u is equal to minus 2. Therefore 1 0 alpha is equal to 0, the other 0 beta is equal to minus 2. The sum of the zeros is alpha plus beta, and that is 0 minus 2, that is minus 2. Alpha beta is 0 into minus 2, that is 0. Now let us go for the relationship. Alpha plus beta is equal to minus b by a, and the b is 8, therefore is minus 8, and a is 4, it is minus 8 by 4, it is minus 2. Alpha beta is equal to c by a, and as you know that c is 0 here, there is no constant here, 0, and divided by 4 is 0. Therefore alpha plus beta is equal to minus 2, and that is also equal to alpha plus beta, which is minus b by a, and therefore it is minus b by a. Alpha beta is equal to 0, but alpha beta is also equal to c by a, that is 0, therefore it is equal to c by a. Therefore we have verified the relationship between the zeros and the coefficients of the given quadratic polynomial. The next example is t square minus 15. So t square minus 15, I have to equate it to 0 to find out the zeros of the given quadratic polynomial. So when I equate it to 0, now I can use the identity here, that is a square minus b square, that is a plus b into a minus b. Applying that, so we have t square minus root of 15 whole square, that is a plus b a minus b is 2t plus root 15, t minus root 15 equal to 0. T plus root 15 is equal to 0 means t is equal to minus root 15. T minus root 15 equal to 0 means t is equal to root 15. Therefore we have alpha is equal to minus root 15 and beta is equal to root 15. Now let us find alpha plus beta. Alpha plus beta will be minus root 15 plus root 15, that is 0. Well, let us find alpha beta, that is minus root 15 to root 15 is equal to root 15 to root 15 becomes 15, minus into plus is minus, therefore minus 15. So now let us find out the relation between the zeros and the coefficients, that is alpha plus beta is equal to minus b by a. Minus b, as you know, there is no b value here, there is 0, so 0 a is 1, so 0 by 1 is equal to 0. Alpha beta is equal to, that is c by a, and c is minus 15, a is 1, so it is minus 15, and you find that alpha plus beta is 0, so also minus b by a, therefore it equates to minus b by a. Alpha beta is equal to minus 15, so also c by a, and that is minus 15, that is c by a, that is minus 15. So we have proved that the relationship between the zeros and the coefficients of the given quadratic polynomial. Now the next example is, we are again given polynomial 3x square minus x minus 4. We have to equate it to 0 to find the zeros, and by middle term splitting method we get two factors, 3x minus 4 and x plus 1. Equating 3x minus 4 equal to 0 and x plus 1 equal to 0, we get x is equal to 4 by 3 and x is equal to minus 1. Therefore the two zeros are alpha is equal to 4 by 3 and beta is equal to minus 1. Now alpha plus beta, that is 4 by 3 and minus 1 is 4 minus 3 by 3, that is 1 by 3. Alpha beta is 4 by 3 into minus 1, that is minus 4 by 3. Now let us find a relation between the zeros and the coefficients. So alpha plus beta is equal to minus b by a, and you know that b is minus 1 here, a is 3, so it is minus 1 by 3. Alpha beta is equal to c by a, and c is here minus 4 and a is 3, it is minus 4 by 3. And we find that alpha plus beta is 1 by 3, 4 minus 3 is 1 by 3, and that is equal to minus 1 by by 3, that is 1 by 3. Here please understand here, minus b by a, minus b, minus is here, so minus of minus becomes plus, so therefore this is not minus, it is plus 1 by 3, and therefore it is correct. 1 by 3, and this is not minus, please correct it, it is plus 1 by 3. And alpha beta is equal to minus 4 by 3, and here also we got minus 4 by 3, and that is equal to c by a, therefore it is verified. Again let me repeat, don't take minus 1 by 3, take it as plus 1 by 3, because it is minus of minus b, because b is minus 1 here, therefore minus of minus becomes plus, so therefore it is plus here, and therefore it is 100% 1 by 3, and it is correct. So please remember that. Now the second example here, we are given sum and product of zeros. Please understand here, given sum. Please understand, there are not zeros given, there is sum of zeros given, and the product of zeros is given and not the zeros. So we are given the sum of zeros and product of zeros, we have to find the quadratic polynomial. So let us go with the examples. Now we are given alpha plus beta is 1 by 4 and alpha beta is minus 1. We have to find the polynomial. We know that the required polynomial is x square minus sum of zeros into x plus product of zeros, and that is x square minus 1 by 4 into x plus of minus 1, that means it is x square minus x by 4 minus 1. Taking 1 by 4 outside, we get 4x square minus x minus 4 in the bracket, and therefore the required polynomial is 4x square minus x minus 4, neglecting 1 by 4. So that is the solution. Now coming to the next example, again alpha plus beta is given as root 2, alpha beta is 1 by 3, we have to find the polynomial. The required polynomial is x square minus sum of zeros into x plus product of zeros, that is x square minus root 2x plus 1 by 3, take 1 by 3 outside, put the remaining terms inside the bracket, so it becomes 3x square minus 3 root 2x plus 1, and the required polynomial is 3x square minus 3 root 2x plus 1, neglecting the common fact, that is 1 by 3 here. Now the next example is, we are given alpha plus beta is equal to 0, alpha beta is equal to root 5, we have to find the polynomial. The required polynomial is x square minus sum of zeros into x plus product of zeros, x square minus sum of zeros is 0 and the product is root 5, substituting we get x square plus root 5, which is the required polynomial. Now we are given here alpha plus beta is 1 and alpha beta is 1. The required polynomial is x square minus alpha plus beta x plus alpha beta, that is x square minus 1 into x plus 1, that is x square minus x plus 1. So that is the required polynomial. The next one is alpha plus beta is given as minus 1 by 4, alpha beta is 1 by 4. The polynomial, required polynomial is x square minus alpha plus beta into x plus alpha beta. Substituting we get x square minus of minus 1 by 4 x plus 1 by 4, multiply 1 minus into minus becomes plus, so x square plus 1 by 4 x plus 1 by 4, taking 4 outside. So we please understand here, take 1 by 4, not 4, 1 by 4, this is not 4, 1 by 4 you have to take outside. So if you take 1 by 4 outside, we get 4x square plus x plus 1. See, please correct this, it is not 4, it is 1 by 4. If you take 1 by 4 outside, we get 4x square plus x plus 1, and therefore the polynomial, the required polynomial is 4x square plus x plus 1. So please make this correction and note down. So that is what is the solutions of the exercises of the polynomial chapter of CBSE 10th standard. So please note down these examples in a book, practice them, learn them, and okay, so that you get a good grip on solving these examples. Okay, thank you.